in a print statement. The parameters fall in order. But print is exception. In addition to supporting fixed length function, fixed length, fixed number of parameters, 1 parameter, 2 parameter, 3 parameter, like C, supports a style of function definition called variadics. A function is a function that takes an arbitrary number of arguments. Variadics, variadics don't come up all that often, but when they're really important. And the print has to be a variadic, is that you want as a user to be able to say print 50 things or print 5 or print 500 commas. It makes sense to you. Print lobby, print on everybody, and have the function do the printing regardless of how long your list of things print happens to be. And special syntax, if the seminar goes on long enough that you will see, and if it doesn't go long enough, it's in my notes. It's special syntax where you can say, here's my A argument, here's my B argument, here's my C argument. Oh, by the way, here's this widget that can be a list of everything else. Do as a function designer is like the print function designers go through the list and say, I will print everything in the list, what the other called by itself. Dave, following what I'm saying about variadics versus fixed parameter style functions. Pretty following. Is probably right. Pat, are you following? Jacob, are you following? Right. Charles, are you good? Gavin, are you good? Aaron, you're part. I'm sorry. Adam Howard, not Aaron Howard. Adam Howard. Sorry. You're good. Okay. So you have standard. Here's my first. Here's my second. Here's my third. You have to do variadics. You also have a concept that I think showed up in Ada called keyword parameters. Keywords come after all of your standard arguments if you ever go to write a function. What keyword parameters allow you to do is drop optional arguments into a function. Here, it's optional because most of the time people will just want to throw a space between everything that gets printed. But if it be fancy, and you've seen fancy here, you change the set if you like, the separator, or change the end. Whoa. And in my notes, if we get this far, the way Python handles these keyword arguments is with extra second special parameter. So you have your normal set of lists, and if you want to create a function that handles variadics, you have a special variadic, and after that, if you want, you have a special dictionary argument, also an associative array. And hence the function is the structure that pairs names of keywords with values. Okay. Whenever Lutz was saying that the new Python, the old Python, you need to absorb a lot of concepts at a superficial level quickly, going on to deeper mastery. This point about the different styles of arguments, one of the ideas is that that's had in mind. I think one of the pretty things about Python is that it looks natural. Numbers followed by this equals that, this equals that. You can look and say, well, what's going on here in the code? I can read that, and it makes sense. Either that, I've been looking at Python too long, and my brain is fried. See, this is as clean of a way if you can express the idea of mixing positional arguments and keyword-based arguments in function action as I can imagine. Comments or questions about handling of the prints. Okay, about the formats. Any surprises here?
Well, if you look at Fortran format, the format is between the formats. It's a little confusing to say that because instead, format is before the format word, the word format, followed by a list of arguments that you want the format to format. It's a little bit confusing to a Fortran programmer looking at it, so.
Two languages. The first two languages I had as a professional were assembly language and Fortran 66. So I coded a fair amount of Fortran 66 back in the days of Pittsburgh plate glass, and I agree absolutely. You program Fortran used to see format on its own line, and statements referencing the format, print, blah, 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 use statement 10. Statement 10 is the format. Procedural language. Python is an object-oriented language. Everything Python is an object. Pretty much like the old small clock idea where you have a universe of objects and objects interact by sending messages to another. So rather than actions being the primary focus in Python, objects are the primary focus. So everything revolves around an object. What is the object? The object here is the format string. Okay? Dot means related to object. So if say, quote, curl, comma, curly's one, dot format. What we're saying is please access the format property of a string. Now that property in Python, some properties happen to be callable, some properties happen not to be callable. Properties behave as actions, some properties are just data. Format example of a property that is an action. Okay, these are called attributes in Python, and objects you can think of as tables of slots. A string is a table of slots, and the different slots say what an object can be and do. Double quote dot format again says, give me the format method of this string. The format method of the string looks for special syntax. The curves are special syntax. You can think of these. I think that there was a language called Frac years ago that had this cool idea called holes. And if you merge, what you're looking at is very much akin to mill merge, where you heard holes. There's hole 0, there's hole 1. Or then values that these are holes, and the net is flipping the values from the into the holes. The reason that next to last fails is that there aren't enough values to plug the holes. Does that comment make sense? I agree with you that it's reversed, that it's reversed because the world went from Fortran natural language to object-oriented.
100 years from now, that will be the same response.
Fortran has changed a lot through the years.
Yeah.
But that way it hasn't changed.
Fortran.
The world includes Fortran. That's all I'm saying. I'm being technical. Well, I'm saying Fortran hasn't gone away.
Oh, no,
The world doesn't have Fortran, but mine does.
well, mine still has Fortran. my universe still has Fortran, and Fortran will not change because Fortran's relative simplicity valuable in what people who say yes what programs are intended to do can do. Okay, Fortran is still what it is because simplicity allows optimization to the max and parallelization to the max. You don't have to think about lines of crazy interactions for the most part. So, well, for example, it's possible to do aliasing in Fortran. You have connect pointers. You get the effect of a pointer by saying or AVI. You get pointers in Fortran, but it's rare the way people code it. Okay. You're doing that sort of thing in Fortran. You're you should probably hang up on the thumbs anyway. Okay? But Fortran is simple enough that you can make it really sing in terms of performance. Okay? The newer languages, by contrast, are expressive. So the question is, how much value do you place on human programmer time? Since this tends to be cumbersome to code in, to do something not related to numbers, how much value do you place on people time? And how much value do you place on getting the computations to sing? As my architecture professors used to say, you have people who are concerned enough about performance, they do handstands to get teams to work. So you really both have this in the universe, but on the whole, since people time is a whole lot more valuable than machine time, the check style, which leads to programs that tend to be much more maintainable. It's not to be the point of the row, except in niche areas where performance is so key.
Welcome to my new area.
It's a critically important niche area, but it's not in a way. But it's the world is not all 4 times 66 is one. No.
77.
Yeah. I remember looking at my first Fortran, and I never coded. I looked at a book. I looked at Fortran 77, picked up a text, and said, "How to while loop in Fortran 77?" Oh, neat. Yeah, great language. So you got while loops. And I said, if they go to 100, 99, go back to. Okay. So there's a lot more going on with the format. I showed just a couple of features of the format statements in the series, but you can do an awful lot. But you don't need to do much to see what's going on with these to get a basic feel for the language. Okay, so here are a couple more constructs. I want people to please type these in and see what they're doing. That's much for each. Four.
Four. Four.
You're typing, yeah.
Actually typing for,
Oh,
typing for my, yeah.
yes, and I've shown a couple of examples. If you don't put the numbers in the curly braces, that tells the format treats that as next argument used. An example, I'll go back through some of the examples, and I won't have people retype them from last time, but I'll show a couple of the findings where I do use the anti-curly braces. I worried out with these with the numbers because I think the numbers are a little bit more general and they're a little easier to follow. And then I drop down to the default, give me the next. Running
Oh, I just have to close that. My, unfortunately, wow.
thought format. Right.
Here we go.
Okay.
How do you do it?
Right. So to save your aching fingers for report. You look like you're taking a brief nap while everybody.
Here, I'm familiar with it.
Absolutely, absolutely. Charles, you look good. We're good. Robert, you look good. Jacob, Patty, are you happy?
Yeah.
A little bit about what's going on with the difference between Python 2 and Python 3. Python 3 went in heavily for iterators. Now, an iterator can be thought of as an object that when to a for loop and as repeatedly yields a sequence or extreme of values. While that doesn't sound like too much that you're not used to, the important thing about an iterator is not actually in a sense. An iterator is much more like what database people call a view. If you database, how many of you are familiar with the notion of a view?
No.
Okay, in database lingo, databases, everybody knows, I assume that relational databases are found in those tables. Assume that. You label in and you write an SQL query that shows you the contents of the table. It's the case in the database world that within the table exactly what you want to show the user. For example, unprivileged user, you might want to show as unprivileged user only a part of a table. Or you might have information scattered over 2 or 3 tables where you want the user to look at that. You might, for example, an employees table, a salary table, employee salary table, and employee longevity table. And you want to create the illusion that information in all 3 tables is housed in one place. So as you create this virtual table called a view, and a user looks up in the employee salary longevity table, and the user sees what looks like an employee longevity and salary table, but really what the user is looking at is a window in 3 physically different tables in the database. Am I making sense so far? It's a little like what happens on a news show, where you have 3 talking heads. It's like all 3 talking heads are in the studio, but physically one's in New York, one's in Los Angeles, and one's in Chicago. Okay? The image of a view is it gives you an image without necessarily copying what's out there to get that image. So there are a bunch of iterators that will give you views of data structures, but won't actually make a copy of what's there. Gives you a view. An example of something that gives you a view and gives you a view of the sequence. In order to transform a range into an actual sequence, you have to treat it. You have to say, I want this to be a data type. And here's the data types we'll look at a little later today, a list. Okay. It is a seek values. That's a one-dimensional array. Jacob's question, this is how you would produce a multiplication table as a list of lists. See that. Okay, and so it's kind of the skinny on the there's something on of lists. So range. Okay, yeah, range. Okay, the range in Python produces what's referred to as a half-open interval. Okay, this is how it goes up to but not including 10. And where do you think it will stop?
In Fortran programmer, we call that.
No, there's a reason. Half-open intervals, it turns out, are really nice to work with in terms of specifying a list of values. For example, if I want to say an empty list, I can say list range 0, 0. An easy way to say I want the list, you don't use something like start from here and go up to, but not including. So I've told people I'm preparing a class on C++. Half-open intervals are all over the place in all of the C++ standard library constructs. Most of the constructs that support operations over sequences, for example, add one to every member of the sequence, the biggest member of the sequence, all specified in terms of half-open intervals. NLP, a language that's tailored to the HAXML, size everything in terms of half-open intervals. Okay, again, half-open means you start at a place and you go up to but not including. And as awkward as half-open seems at first blush, it's half-open from what I've seen of the language that I've worked with, and it's pretty much become the standard for specifying the intervals. Okay, so that's pretty much what I wanted to say about these examples, the idea of an iterator, the idea of an iterator like range providing a view. You can Python optimizing world by constructing the sequence back there numbered from 1 to 100, range being a view of this standard sequence somewhere in back of it, and idea of half-open interval. So there's just one more slide that I should have done last week before starting the example. This is single for loops, double for loops, and indentation. And the point here is be very, very careful making sure that your spaces stack up. Please see what they do and see what you think. Okay, that's very awesome. Yeah. Good. I noticed that. Even though I have it over. And Dave and Christy over, like they take over for me for the next few weeks. Behind you.
Oh, okay.
Okay. 3:30 tomorrow has been canceled. Much cause for much rejoicing. Have things stabilized? Pretty much. So, are you doing it? And wait. Yes. Okay. Okay, now I'm going to say something. Not example. This could have got incredibly food. In 20 years, that if you're dealing with a one-dimensional structure, you need a single for loop. If you're just two-dimensional structure, you probably had a nested 2D. If you're dealing with 3 dimensions, you were probably dealing with 4 inside of a 4 inside of a 4. And so if you were dealing with an n-dimensional structure, all things being equal, you had n nested 4 loops. And if you had n nested 4 loops, you were probably getting something n-dimensional back from your 4 loops. Again, it took me a long time to figure that out.
Very important, so it's something that we can do.
Right. So, all two-dimensional examples. You see the format statements can get more elaborate. The colon notation means that there's trickiness out to the right, and special stuff going on that's not default. Here, the letter means left justify, means give me a field that's 4 spaces wide. And you can run these again whenever Bobby distributes the size. Equals means center it, field of 5 spaces. That means right justify, and it's with 5 spaces. Last time I also showed you how to define a function. Define a function, you take what's called a def statement. Def is short for define. And what's cool about Python, one special about Python interpreted language is that definition is an executable statement. If you run the def, there is no such thing as math table. After you run the def, if def succeeds, then this object called math table comes into being and shows up in your environment. And later on, I will show you how to get access. These slides show you how to get access to your environment. Preview. If you want to see what all you have in your environment, there's a function called dir, which is short for directory. And we'll tell you all there. And some that x equals 3. And I read dir shows up. Yeah, see, we want to get help on something. There's also something called help. Let's see if I can say this. And just me far more type out than everyone will get, because there are an awful lot of built-ins. You can see that there are an awful lot of built-ins by saying they're built-in. I'll tell you what all is built in language. And I have a couple of slides at the end of this section, slides devoted to something to keep in future attractions. But def, coming back to the point, def puts a object called math table into the environment. It makes a module available for use. In the current section, modules are objects like everything in Python, and get at a module's add code, you say module.add, or in this case, the module named operator.add. I was asking about the number list. I showed that last time. If you don't use numbers, you pick up the first one of these curly braces, picks up the first in the list, the second picks up the second in the list, the third picks up the third in the list. Okay. Also, pretty much over old ground. I started some things with floating point. showed an example, didn't have you type it in, won't have type in, they let you run it later. It shows you that, as in Trend or other languages, with floating point, keep doing math on floating point numbers, you can build up error. Just you keep measuring, you get round off error. And because if you're with floating point numbers, you have error, you can test for quality. You should not test for exact equality if you're writing an algorithm that tries to determine, for example, if two calculations about a position of the star done in two different ways are the same. What you need to say are these two calculations so close that I can believe that they probably were the same. I have a round off error on one mistake or trend coding. And I was just to say, is A exactly equal to B, when you should be saying, is A within a reasonable tolerance of B? Okay. X values, bring these to it. This will take you all of 30 seconds, just the point. You define J, what you'll get is right, something other than if you try it again here. One other thing you do in Python, the language giveth, the language taketh away. If you define J, you say plus J, and I get, I should have said 1 plus J. See the example below up. Try the following. Okay. Now say sure, J is still in the environment. And if I 1 plus J, example should now break. Del clears junk from your environment. We have an example of a function that deletes itself. It deletes itself. It says, I'm going away by. Because you need to, but more generally, you need to tell on that it's not a variable, because otherwise J follows the rules for defined identifier. And if you don't say 0, it thinks it's an identifier. Okay. Okay, so quasi-numerics. How does it see roots here? Booleans are really integers. I'd like you to try these particular, see what you get.
There's a double quote.
Double quote, yes. Yeah. Welcome back from where you were. It's double quote, single quote, and then coming back out. There's a single quote evaluation and eventually a double quote.
Yeah, but that's first single quote, first double quote.
Yeah. It's in the font's a headache, but yeah. PowerPoint, if you don't disable it, very obligingly converts
I
quotes to smart quotes,
I know that.
which is this code, you copy and paste it, and if they're smart quotes, it won't run. You've seen, yeah,
I know. It's a pain.
yeah.
I'm sure there are lots of
There's, you have to go to, there's another person I read once that GUI are not easy to use, command lines are easier. You have to know exactly where to go in the interface and go 5 levels deep and find them. Yeah, yeah. One I read years ago said GUIs are like angry fruit salads. There's all the colors and all the stuff mixed together, and you have to pick out what you want.
Tonight is the food salad story today.
Oh, yeah, what's that?
There was out with onions.
First, they had fruit salad with onions in it,
That's unique.
isn't it?
Not the garlic.
I don't have my AirBot with.
Oh,
Yeah,
that's one reason for using an editor without and pasting.
right, you got me there. you said we're supposed to do that, and I'm not doing it. So, I get what I'm doing.
I found it's convenient to run these. You have a text there on one side and copy and paste it in the Python window. And that way, whenever you screw up, you don't have to retype it.
Might for going up to
Up arrow.
previous command, or down arrow to the next command, or going left and just, you know how you do in the shell normally, you use the arrow key. Well, I'm just running Python 3 on my Mac, and I just don't know exactly how to fix that problem. Or it's acting like a shell, and you are? Well, not better. I don't know. If I run, shell, I run Python 3, which is good characters,
Are we a instability?
I control food. I control food.
Control food.
For what? No, it's definitely.
Okay, so she established this weird convention that if it's 0, it's false. If it's not 0, it's true. If you put value in an expression. So, strictly speaking, true is not 2, true is not 3, true is not 4. And if you try to identify true and compare it to 3, as the Python will tell you they're not the same. But if you stick 3 in an if test, 3 will show up as true. Similarly, empty lists and structures regarded as false, and non-empty structures regarded as true. And I've actually seen that convention in other languages. But I wouldn't recommend using it either, but it's there. And I show it because the feature is part of the language, and it's something to be aware of. Okay, so for me, it's not surprising that floats are subject to round-off error. But string conversion, you saw last time that whenever we played with big nums and did 2 to the 100,000th power, that the 10 to the power wasn't what took the time. What took the time was turning the 2 to the 1,000th power into a string. That it the conversion from binary representation to text, chewed and chewed and chewed and chewed. And that's not surprising either. I mentioned a mainframe convention called BCD that is we sacrifice some space to put each decimal digit in its own place in a string. That's what BCD does, is reserve 4 bits to encode every digit. So you get a fair amount of waste in your binary, but what you get is the ability, you know that, for example, that the 44th digit in is exactly 175th digit in, rather than the 54th digit in is somewhere depending on how my binary got stuck together. And what BCD allows for is total version between and nerd output. If you're creating a bunch of pay text, for example, that makes up a lot faster. Okay. You're old enough to remember BCD. Yeah. Hey, did you ever work with? Did you work with COBOL? Did you work with BCD and COBOL? Okay.
About it, but I never used it.
It's pretty much gone from contemporary languages, but my guess is that BCD is still very much a foot in the mainstream world.
We work with
Well, I find it a little surprising that Python equates empty structures with false, non-empty with true, but I've actually seen this before in a language called XSLT. I mentioned from time to time. If you ever have to work with XML, learn XSLT. Don't learn Microsoft XSLT. There's stuff out there going on. The difference between 1.0 and the newer standards is like the Wizard of Oz spoons in black and white and Technicolor. Bypass Microsoft XSLT completely. Best XSLT engine on the market, manufactured by a British firm called Saxon. It's a beautiful language, and it's the quirkiest language. It's the strangest language I've ever seen, but it's beautiful in the domain that it works in. And the Michael Kay, who's one of the authors of the language, the Fox book on XSLT is a terrific reference. It's references that I've ever used on anything, right up there with Rust, with C++, or Cannon's writings on distributed systems. Okay, I'm surprised. Big num math is as fast as it is. You can take 2 to the 100,000 powers quickly as you can. That is just, or million powers. That is just impressive. I'm on my laptop. I'm surprised that INF is not a number, which are IEEE 754 standards are not keywords. They float and friend, quote, INF, close friend, unquote. And if you go back, Charles, I showed this last time. Right, this is how you ask for infinity, the infinity value. And you wait for not a number. Float, open friend, quote, NAN, close quote. Okay? I'm surprised there aren't keywords. I'm also surprised that Python does not detect underflow natively. I have an example here where I show 10 to the increasingly vanishing powers, and you get smaller and smaller and smaller. All of a sudden, you get 0. In languages and hardware, you get what's called underflow detection. I'm also surprised that 2 divided by 0 is not infinity. Rather, Python throws a divide by 0 except whenever you try to divide by 0. Maybe that's smart, but in a sense that because dividing by 0 is usually inherent, the language that supports infinity, I would expect to go to infinity. You would like that? I don't think you can. I do not know if you can. Python way, like language like C or C++, where you can say I have a float or a double or a long double, on, for the sake of convenience, mushes a bunch of stuff together. It takes away options. I think that that's one option that you can get around.
You could test the exception, and then
Okay.
you could test the exception that gets the
Sure.
and the exception with the size, your value to be.
You do that, but you can't have the language directly go to Infinity for you.
If you want that behavior, you have to write it yourself, but you can't write it.
Okay, now going to what you would have to do some computation on the side or use special module. There are a couple of modules in the standard library. There's one called Decimal that apparently does actually explicitly manage underflow. There's a module called Fractions where you can fraction arithmetic. You can say 1/3 plus 4/5. It won't give you a fraction back. The Lutz book covers both at some length, like 6 or 7 pages devoted to both of those in Lutz. I bypassed them. It was as useful to know about, but important as a first introduction. Okay. Other item, and I didn't have you look this carefully, but if you're dealing with floating point numbers and you need to do comparisons, there's this thing called sys.floatinfo.epsilon. Sys is a module. You import sys, as I showed in my example. Epsilon is the smallest representable floating point value. And epsilon value is a classic. If you look at C, epsilon is in C, epsilon is in C++. So, that's what I have to say about numerics. More about types before we go into structures. Please try the following. Types are actually first-class values in Python. You can ask for a type and compute. You can get and compute with a type. I will.
I'm not looking for an type. We can have them 3 types, can't you? That's what we're saying.
You're just getting tired of typing.
Laugh at me.
You're getting tired of typing.
Muscles are tired, but these muscles apparently are not so
Well, I
apparently too much.
Fucking back 3 times fast.
You're doing it up there and change that value.
I'm never gonna fucking do that. This is the person.
The point, there's a point to what I'm asking about.
Second type. Yep.
Yeah,
The type of the type is
That's that.
I tried 1 and 4 a lot of didn't do much a lot of
no, well, there's a convention in a lot of object-oriented language going back to the Smalltalk. Actually, the problem of type systems and infinite regress goes all the way back to Bertrand Russell. The Vivia Mathematica. How do you try to get Texas out of math? If you're familiar with the Barber paradox, the barber is the barber who shaves everybody with those who shave themselves. if he shaves himself, or the barber shaves everybody, does not shave himself. If he shaves himself, he does not shave himself. The barber shaves everybody who doesn't shave himself, right? And so it's kind of like Zeno's the classic Greek paradox, and which is effort at the turn of the century to try to use type systems to get free of, and mathematical logic free of paradox. And one of the issues is what is the type of the type? What happens when you back up to a certain level? If you have systems like the one we're seeing here, it's sufficient to say type is type. Small does this, Java probably does the equivalent, C# does the equivalent. At some point you can say the type of a number is a class. So types, classes is the same thing. Python 3. Python 2 they work. You got old style classes and new style classes. New style classes in Python 2 are types. Old style classes weren't because they don't inherit from object. Okay. Here's another type. Try this. I'm not going to say that much about type systems in Python, but I do want to say a little. This is pretty much original from the type system stuff. Right, because what you have, when you say plus 0j, what you do is you introduce a second imaginary component, and it becomes complex, yes. And as class complex, again, in Python 3, everything that's a class is a type and vice versa. Okay, do people see what's going on with none and none? One interesting things in Python is that if you have something that's not, and you ask the top level interpreter to print it out, you get nothing. If you just solve, you get nothing out of the result. You say print result, get none. And if you say what type of result, you get none type. And that's, to me, that's being aware, because before I understood that if I got none from a computation, nothing would happen. As I printed it, I got confused. So I'm trying to go through that a little bit more slowly. Does nothing. Is a statement in Python that's like no equivalent in assembly language. It does nothing. It's a placeholder. You have to have a statement, a function body. You have to have something there. It's a Python rule. You just can't leave this blank. This means I'm leaving it blank. I'm doing nothing. So if it does nothing, returns nothing. Top level Python interpreter, the interactive Python shell, operates a little differently from the language, because the top level shell is meant to be for user convenience, work more at the desktop calculator. There are a few special things that happen with the top level that happen ordinarily. One is it's the top level doesn't print none. It's nothing. It says returns nothing. It returns none. Now, if I resolve, it's nothing. going on here? What's going on is if you use the print function to solve, then print will actually tell you the value of the result is a special value called none, that the top level interpreter suppresses when it goes to print. It asks for the type of none. It's a special class called none type. It has exactly one value in it, none. So, well, that's a little bit about the Python type system. From the next slide. Okay, now I have more material on typing in Python, but it comes later. Let me go through it quickly. Move on to structure. If your background, we're with Java or C#, or even Fortran and languages, C, or even Fortran. Every variable has a type. Fortran, IJKLM, and if you're right, everything else began with any other letter of the alphabet was automatically float. Okay. You can also have implicit declarations. You say implicit A integer, then everything deals with an A. Fortran, even though it doesn't look like it, every variable has a type. C#, every variable has a type. Java variable has a type. Variables don't have types. Objects have types. Variables associate with objects. And be an integer, and then flip to a complex, and then flip to a list, and then flip something completely different in the course of the same computation. People favor that have compile time type checkers. This is an evil because you can get confused and actually screw up your type. And it's good to have a compiler looking over your shoulder. Of interpreted languages say, if you screw the types, you're stupid. Essentially. The names alone ought to be enough. If you're with something called foo, you know that you can't mix foo and bar just because you have a name foo and you have a name bar. The people, and I have a slide devoted to this, maybe Chris will get to it, people who advocate the sort of type checking will say, you type checking in Python, and you can. You saw that is an instance where you see if a value is an instance of the type. You can write that. The hardware will say you never want to write it because it always costs time to do the type checking at runtime, and the compiler does it for you once and for all, and you don't have that overhead at runtime. The core like what will say checking is occasionally called for. But it's type checking in your feeble-minded. Also, in art, there's another style that of code that I think is universally disparaged by Slide called runtime type inference. You create a big case statement, and you try to do different things based on whatever type of whatever it is you're dealing with, and that is bad. But well, it's not only is if it didn't do this, if it's full, do that. If it's close to the third thing, if it's a class, do a fourth thing. If it's class, do a fifth thing. Bad. It's also for maintenance. If you ever take away one of the types, add a type, all the code that does the runtime type inference has to change, and all the client code potentially has to change too. So what you have is you have this tight coupling of, and it's you don't want to ever write code that says if I have type A do this, if I have type B do that. I just want to make people aware that there is this debate. There is two camps in the language community who have very strong religious feelings on both sides about the benefits of typing and type checking. Okay. So I do have one or two slides later about that, but just to make you aware, I wanted to show types, and I want to move on. Because for the most part, you don't really need to know what type of things are if you're in code in this language. Okay. Structure. You can down the types, built-in types, fundamental types. It's that sequence the kinds. Here's 1, here's 2, here's 3, here's 4. And the don't sequence. Type don't sequence, just hashing. Puts into structures and picks stuff out of structures.
The word hashing is not clear.
Trying to think of a good way. Here's a way of explaining hashing. Here's what I did. I said to my wife when I tried to explain the whole. Picture a strategy for looking up people in an index where you took the second letter and fourth letter of the first name, the third letter of the middle name, the letter of the last name, the second digits of their social security number, and maybe a couple of odd characters from their street address. Use that power letters to generate a number, that number to look for slot in the table. That's it. And the reason it's called hash is you take some properties of a thing, you make a hash of them. And you hash them in the hope that what you get is enough difference from person to person, in my case, my IRS case, let's say. You get enough difference that you make the table big enough so that if you have 50 Smiths, you have to go through a list of 50 Smiths to get to the right Smith. This combination of letters, you get a slot immediately, you get to your slot quickly. Okay, and the hash is like trying to assign a unique identifier for quick lookup based on the characteristics of the objects in your pool of things. Is that making sense? Okay, and Python does is it uses hashes. But doesn't use letters and social security numbers. But Python, I believe, hashes on its memory address. Okay. Essentially, you have these types of structures. And today, next Wednesday, whenever Chris takes over, I think we'll be looking at lists and tables. Okay. And slides are meant to show you is the fact that lists and tuples will show you that they're pretty much interchangeable. I'd like you to try typing this something and seeing what it gives you. The way are squares and tuples and curls.
What do you call
No, those are curly brackets. Parentheses and square brackets.
Okay.
Apologies. Friends and square brackets. That is all classical, right? Are you good so far? Charles, are you good so far? Jacob, are you good so far? Are you good? Jerry, is this? Yeah. You were typing everything and you were about to do a picture, right?
Yeah.
Right. You're about to do a put on the end.
Yeah.
And this is all this is all good so far, right?
Yeah.
Okay. So far, no difference between tuples and lists, except that tuples suffer from a lack of characters on the keyboard. Essentially, there is not enough situation to go around everything that most languages want to do. And Python got around putting tuples in. They didn't need other bracketing characters, so they used parentheses. Unfortunately, parentheses are also used for order of precedence, like A plus B, open close parentheses, times C. And because parentheses have this double meaning, the convention was adopted. If you ever want to do a singleton tuple, you have to put a comma in. If you don't put the comma in, then what you have is a group of expression. That's have to say parenthesis 1 comma. If you just say parenthesis 1, what you get is an integer. Okay, so let's try. Tip the hat since it's getting late before we do the next slide. Okay, T equals 1 comma 2. List equals 1 comma 2. T 0 1. That makes sense, right? T is going to be 2. F 0 is going to be 1. L of 0, L of 1 is going to be 2. If my L of 0 equals 29, I can have for L, that makes sense, right? If I say T of 0, getting 29, and that's a big difference between tuples and lists. That difference is not present in languages like Ruby. Ruby did not make the distinction between essentially the same structure, one which is frozen when you create it, the other which can be changed. This distinction is in Python for reasons of performance. And Chris will show the slides next week if we run out of time. Languages generally start to get messy when you start to put constructs into languages that make a difference because some things run faster and some things are easier to use. Here, the performance issue deals with associative arrays. Associative arrays later on. An associative array is a structure that allows you to say, here is a key, give me a value, hash based. Here is the key, Phil Pfeiffer, give me employee of ETSU. Here's the key, shared. Returns a value, employee of Mississippi State. Here is, so forth. In order to get fast lookup on dictionaries and formats, it turns out that you can get better if you freeze your keys. The keys aren't changing as you add stuff to the dictionary. Then you have to go back and fix things whenever a key changes. Okay? When you come to dictionaries, allows mutables, features like couples that are guaranteed not to change, key dictionaries. Types not allow lists as keys for dictionaries. And that truly is the big reason for distinguishing between tuples and self-performance. So whenever you have distinctions based on performance, language, and a couple other in Python, language gets messier because you essentially have violations of what professors call the law of least surprise. The law of surprise says two things that are similar should be similar, two things that look different should act different. Here you have two things that seem similar that act a lot different. The thing that's worse, users of a language, than violations of the law of least surprise is crappy performance. Okay. So the distinction between tuples and lists is really one that's in there purely for purpose-based reasons. Okay, so do a couple more examples, and then Chris will be the victim. We'll turn over to Chris. Try these examples. I can only try one side. I've already told you that the pipeline, lists and tuples are the same as long as you don't change. Pick the side or the right side for the sake of time. Let's try the one side. You and Al. Are your braces, you think? Square. You have two curly. You need the next one needs to be a square. Okay, that's better. And you. Actually, the other thing is you put back over it's just a curly colon. That's the sense that you cover more. One to the left. One to the left. Put a colon in there. Now try writing that. Turn. There. Sorry. Second on the tuple side. do is I wanted to pick these examples off and run them, talk about them. Okay, so you have this concept, this cool concept in Python. Frankly, I've never used, but it seems useful for something. Okay, probably parallelization or high performance computing. And that's I've included this concept here in these lectures because we're in a high performance computing environment. And a classic strategy for dealing with arrays and high performance computing is you section the array and you form different pieces of sections off to different processors to do something on. Slicing allows you to pull out section arrays. And here we have an example of a forward slice, a slice from, and a slice up to. Okay. 0 colon means give me everything from index 0 going forward, 1 colon, so forth. The other way around is give everything from the start going to a particular end range. And syntax is actually tripartite, and we'll ask people to do is to try these. You can get slices, and if you type what you had into a word processor or something allows you to go to do up arrows, go back and stick negative signs in front of the last two that you typed, and see what's with the negative slices. Negative. Yeah, so pretty much everything from here is what we did already. Everything up here is what we did already. I repeated that here on these slides to make the slide self-contained. This stuff is the new stuff. Are people the negative splicing to work? Charles, you get the negative.
You're getting answers not working.
Okay, let me run it. Let me run what I'm getting and see if you got it. And pull what I've got. Let me grab mine. Paste it. Okay, so for positive indexes, indices, look at the list from left to right. Negative indices go from right back to left. So -1 is the last, -2 is the next to last, -3 is the next to last. So L, -1 means go up to, but not including the last. -1 colon means start with the last and come forward, the one after that. not sure. Another variant of slicing. It's slicing with strides. And I'll just run these. People are short on. We're getting close to the end. Slicing with. Oh, you can do ranges. I'll do ranges and I'll do strides. Here we'll arrange some ranges. Yeah, the idea, I think, actually probably goes all the way back to the old ATL compilers. There got back in the 70s who on compiling ATL, and this idea of slicing and striding through arrays goes back to the 70s. This was introduced, it was introduced in Fortran 30. Fortran 90 does this sort of thing. Okay. You could also do striding, where you can do every first, every second, every third, every fourth slice. Instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can grab 1, 3, 5, 7, 9, 11, just as I showed you earlier with the third parameter for the ranges. Okay, this is a good place to stop with this slide because it pretty much takes the brings slicing to a close, and I really think that slicing is cool, but it comes up after slicing. I use far more heavily the comprehensions and such. That will be Chris's take on next week. Okay. With regard to the slicing wrap up, you can do slicing with explicit striding and start and stop. V1 : 2 means start with index 1. Start second into your list and pick up the second, the fourth, the sixth, and the eighth. If you try to slice with the stride of 0, 0, 0, 0, Python bombs you. Your stride can't be 0. And there's slight asymmetry that if you want to check out in my notes, you can do that. And it gets useful is it? It's a new concept. A very slick way of saying, give me a chunk of an array in a particular way. Slicing is a standard topic in every Python reference that I've seen. It's in Fortran 90. The idea goes back to ATL. But because of the sorts of codes that I write, and currently I'm not working with arrays, rather I'm working with a bunch of named data of various sorts and piling it all into a class. I just use slicing all that time. Cleaning up is the lot more. So be your next Python, same Python channel when Supercrisp takes over the next 2 weeks. Are there questions about what I said today? Thank you all for coming and listening.
We will probably be in this same room next week. It looks like it's kind of got on the core. I'm good for that. It'll be in this room unless it's sent out an email.
What I'm going to send you is a cut down of the first 40 slides. And then you can distribute the first 40 slides to everybody. Here the people will have a text I've done at this point.
I am also gone next week and the week after. We'll be running 11. Yeah, a couple of them upstairs, so they can be up here. But I'll different directions, but just I'm just going to be in this room and we'll figure otherwise. Everybody knows emails for the Python 4 list? Well, once you send me an email, I'll add you to the list. RJR at UTKDU. MWJR at UTKDU. Yeah, original as I thought.